stuff community, with the science community, with the informal science. We have a lot of different partners, and it's really a thrill to be able to work with so many different groups. So thank you for your support, and thanks everybody for joining us. And also, if you're watching, sometime during the broadcast, take a minute and send in a comment. Let us know where you're watching from, because we know we have several thousand people tuning in right now, but it'd be interesting to see where you're watching from. So we're gonna chat a little bit. We're getting kind of excited here because Totality is only 11 minutes away. So we're gonna chat for a little bit, and then we'll take a little break as Totality starts. So let's until then, let's take some questions. Here's one. What's in the media? You've probably seen that this is called the Beaver Moon, or the Beaver Red Moon, Blood Red Moon, different nicknames. So let's talk about what that nickname, the Beaver Moon, means.
So I don't know about the Beaver Moon itself, but I do know that you know, each full moon has a different name because it was used as an early calendar system, right? And a lot of times they are associated with the names are associated with things common for that month, I guess. You know, there's it's not coincidence that there's roughly 12 full moons, roughly, and that many months, right? It was used as an early calendar system, just like the zodiac was used as an early calendar system. Either people that were lunar centric or stellar centric when they were kind of figuring out these things. I feel like the full moon is easier to track for me because you don't have to be up at night. You can see like, hey, it's going through its phases. It's new moon. It's you know, waxing and waning, and then you can sort of guess, hey, that's when the full moon will be. You know why specifically Beaver though?
Yeah, well, the like you were saying, that each one has a specific one, and it kind of has to do with something that's happening that month. Like the harvest moon in October is harvest time. The Beaver Moon, there's a couple different ideas of what that comes from. One is that it's when the trappers would set the traps for the beavers, or also when the beavers are most active before winter sets in. So it has something to do with activities of beavers. So it's just a general nickname. It's not scientific. It's part of the culture, and how people have looked at the sky to tell time and associate it with seasons and things like that. So like a lot of things that, you know, the moon has so much cultural history that, and those names really refer to that. Here's another question: is the moon bigger than Earth?
No, it's like a quarter the size. It's like that apple compared to your face. That's but a lot farther away. People think that the moon is like, it's like, oh, here's the Earth and then here's the moon. No, they're really far apart. If they were to scale of like your head and your fist or an apple, it'd be like across the room. Like
that's about the diameter of the United States, contiguous to the United States, roughly. And Pluto, by the way, is about half that size, roughly. And so, you know, we think about, you know, Pluto being discovered here, and for years, Pluto was a dot. That was about it. The best telescopes, all we could see was a dot, because relative to the other planets, it's smaller, a lot smaller, and also it's further away than the others, so it's just a dot. In the 1990s, a Lowell scientist named Mark Bowie was one of the lead authors on creating the first maps of Pluto. There were just kind of dark and light areas, the albedo changes. But not till New Horizons went by in 2015 did we see Pluto as a planet in terms of how it looked with the heart shape and everything.
We missed one question that I had set up a callback for. Someone wanted to know if the moon will be blue. No, a blue moon is just what you call when you have 2 full moons in the month, because it's not exactly 12 full moons. And I believe the blue in it just comes from like the same reason, like a blue ribbon moon, you know, like that kind of thing. Like that's that special bonus moon that you get. I just thought it was fun. So I was like roughly 12, and then we skipped it. I was like, no, people are thinking of a chart.
So here's another question: is it true Saturn will be seen up close also? And
Not,
not like the moon.
are we at opposition? No.
Well, we're when Saturn is roughly closest, opposition was a month or two ago, when it was closest. But Saturn on average is 880 million miles away. Jupiter's half that. The moon is 250,000 miles away, 240,000 miles away. So the moon is always going to appear the biggest of anything in the sky of the bodies.
Yeah.
Mars gets closer and further away, but Mars will never, contrary to the August, 2000, news report that came out every August that Mars was going to appear as big as the full moon. That just isn't going to happen. It'll be closer than on average sometimes. It's still going to look like a dot in the sky.
Yeah.
So Saturn will be closer, and it might sometimes it'll appear a little brighter, but it's still going to be just a point of light.
I do know that when the moon hits its stable, when it stabilizes, like we know that it's moving away from us, but that will slow down and eventually reach an equilibrium, and at that point the moon will be a tiny little dot in the sky. It will not be very big, so enjoy it while we got it, folks.
Yes, right. So here's a question from Cecil: how does the moon affect the human body?
I think it mostly affects it with like circadian rhythms and things like that, like and the light. I know that the tides, I mean, our bodies are mostly water. We're basically just bags of water and bones and stuff. I know, doctor, but I don't believe that the gravity effect you can, like, it's noticeable. You do get these big tidal bulges, but a lot of that is from the lack of the moon as well, like the lack of gravity from on the far side of the Earth from the moon. So I don't know if it would have too much effect on the. No, I mean, gravity is everywhere. Gravity affects everything. It's constant field, right? So it has some effect, guaranteed. But is it noticeable? Not to me, not day to day.
Here's another one. Here's a good question from Little Cloudy. If someone were on the surface of the moon during a total lunar eclipse, in the spot where the eclipse is visible to us from Earth, which is pretty much the whole face of the moon as we see it, would the red shadow also be visible to the person on the moon?
Probably not, because it would look exactly like a solar eclipse, but it would cover a lot more. And so I think the effect of staring at the sun would block out any of the red.
And you talk about red, we're only 4 minutes from totality, 3 minutes from totality beginning. And when we get there, we'll probably take a little break so we can run out and we'll take a break at 3:20. We'll talk about it a little bit when it goes in there. So we'll take a few more questions here. Why is the eclipse not happening again for 3 years? And we'll talk about these as our viewers change. We'll answer these questions. Sometimes the same question throughout the night, but it's good to revisit that. Why we had one earlier this year in May, but we don't have another one, total lunar eclipse, until 2025.
Yeah, you have to be in a very nice, perfect line with the Earth, Moon, and Sun to make it work, or the other way around as well. They have to be lined up perfectly, and their orbits aren't always perfectly lined up. And when they come back around and they have to be in the right spot, then we get them.
So we've got a lot of great questions coming in. We'll get to as many as we can right now. Why is the moon so bright?
It's being blasted by sunlight. It's actually pretty dark. It's the color of asphalt. But the moon is shining extremely, or the sun is shining extremely brightly on the surface.
And here's another question about size. Is Pluto the same size as Mercury?
No.
And no, we'll go on. No. we're just mentioning how Pluto is the smallest of the traditional 9 planets, and it's about half the diameter of the United States. To give it, yeah, so it's a fair bit smaller. Here's a question: what's the supermoon?
Supermoon is when the moon is also it's basically as close to Earth as it's going to be in its orbit, so it looks bigger by a measurable amount.
And here's a question about Saturn's rings. Are they made of moons?
It's made of ice, and they're going away as well, so they're transient. The fact that I think is cool is they are newer than the Appalachian Mountains, and they will be gone before the Appalachian Mountains are gone.
And it's interesting with the rings of Saturn, because they're these ice balls and they're mixed in. There's at some point, what do you call a moon? It was just a chunk of ice.
Yeah.
And it's how do you define it? But if you were to look at Saturn's rings, they extend from one end of the ring. If you extend it to the other on the other side of the rings, like if this was Saturn's rings, Saturn's in the middle, from one to the other, that's about 3/4 of the distance to the moon. And yet the width of the rings is only half mile.
Yeah.
So very thin layer. Let's see. Couple more questions here.
Lost Planet Nibiru. Check out the podcast, Star Stuff, where we talk about interesting theories.
Here's a good question. That's good for us to remind ourselves about. Can we watch the lunar eclipse with the naked eye? And that's a great question because we think about solar eclipses, lunar eclipses. Is the moon going to be too bright or not? Whatever. You can look at the moon anytime with the unaided eye, with the naked eye. It might be kind of bright. It might be a little bit bright to look at, like looking in the headlights of a car when it's really bright, but it's okay. The sun, on the other hand, you should never look at the sun. If it's a solar eclipse, the only time you can look is when it's completely, totally eclipsed. But if it's partially eclipsed, you don't look at it because you're going to damage your eyes. So it's okay. It's okay to look at a lunar eclipse. You're not going to do any damage or anything like that.
I think we're reaching into totality now.
Yes, we should be at totality right now. And so for the next hour plus, go take a look at the moon, because it's going to appear. It should appear. We haven't seen it yet, but it should appear nice and kind of a reddish color. And so we'll take a few more questions as we're getting views of that. And then at 3:20, we'll just take a break and just let everybody just go and enjoy. So we're just kind of scrolling through more questions here. As the moon gets farther away, won't it eventually leave our orbit?
No, and I kind of talked about it a little bit earlier. It will reach a stable point where it's it'll actually be fully tidally locked. There will be no wiggle anymore, and it'll be pretty far away, and it'll be pretty far in time from now. So
yeah.
You got some time to enjoy it.
And thanks to Sarah Bircher and our entire outreach team, education team, for getting us the telescope views. Sarah was just commenting how when we've been leading up in partial eclipse, sometimes it's hard to get a good view because the camera is going between the brightness of the moon and the darkness, and so the exposure can get kind of funky. But once the moon's in eclipse, it's just this consistent reddish hue.
Mm-hmm.
It's not real bright in one area, real dark, and so except for clouds, the views should be real consistent that we can see. Why do we not have eclipses for other planets?
We do. They're called transits. You see them often enough.
Okay, what would the Earth's atmosphere have to be made of to make the shadow on the moon look blue?
Oh.
What elements would that be?
I don't. Not a billion years. I have no idea.
Yeah, I don't know what that would be.
I don't know what would scatter to blue effectively like that.
Here's another question. How do we track the north and the south node of the moon's orbit? Is there an astronomical difference between the eclipses at either node?
We just look and see the point that it rotates around, right? The magnetic field of the moon is non-existent anymore. we have glass beads that have had the Earth's magnetic field embedded in them from impact. So like it would just be a look at it wiggle, look at it rotate. That's kind of the line.
Yeah, okay. And again, let's revisit again why it appears red.
Yeah, it's red because the sunlight can only shine around the Earth, and basically Earth's atmosphere is refracting the light and scattering the light into the red, and it's the same reason we get sunsets. So if you really want to think about it, the only light hitting the moon during the totality is sunset light.
Mm-hmm. Here's a question from Kayla to both of us. Do you have a favorite moon phase?
What about you?
I guess probably a full moon because the romance of it,
mm-hmm.
the cultural history of it, and the fact that we can get an eclipse.
Yeah.
So I guess probably that. Although I also like first quarter for viewing.
Yeah.
Third quarter is great also, but first quarter, I guess I'm more familiar with that side of the moon.
Mm-hmm. Yeah.
So I don't know. I'll take anything with the moon.
First quarter is mine because you get a lot more. You can, as the terminator of the moon, like that's the sunset line crosses the moon. You get like it casts deeper shadows in the craters and all the geology stuff that I enjoy.
Oh yeah, and I like first quarter because some of my favorite, the Apollo history and the early flights, like Apollo 11, is fun to be able to point out where they landed, and you get that during first quarter. Also, there's sometime around the first quarter when you get Purbeck's cross, which is that phenomena. It only happens during first quarter for a couple hours, where you get this phenomena where there's several different craters. I think it's like 4 craters, and the shadow is just right where it's crossed.
Oh, that's fun.
It's called Purbeck's cross, and you can't even see it every first quarter. Everything has to be just right. I've had this question through the years. Also, my favorite thing to look at through the telescope. And there's so many great things, but my favorite's the moon.
Yeah.
Because geologists as background, you can see analogs, things that we're familiar with, and the details and the history of going there and going back there.
You could explore it for forever with a home telescope or even just like a binocular set. There's so many cool features on the moon, and every day brings new features to light as you view because of that terminator line crossing.
Yeah. And I think since we have so many questions, let's just keep answering those as they come through. And we might take a little break in a few minutes, but we want to try to get as many questions as possible. So why does the moon not look as red in Houston, or does it?
I would say it's probably a combination. We've got a little bit of enhancing of our with the telescope, right? It's going to be able to see a lot more than your naked eye can. I don't think smog has much to do with it. I think there might be some effects from like light pollution in general and just humidity.
So it's not necessarily the geographic location; it's local conditions.
That
might have something to do with it.
We've been pushing dark sky stuff since Percival Lowell basically got here. So.
And I just put on my Houston Astros hat in honor of Cody, who's managing all the operations here, our marketing manager and guru. So she lived in Houston, and of course they won the World Series, which some people like, some people don't, but we just hear cheering back there. But the Astros are tied into the moon because in 1962, Houston got a new baseball team. They called them the Colt 45s, and they played at whatever stadium. But in 1965, a new stadium was going to open called the Astrodome, and it was named after the astronauts who were training in that area. And so the team decided to change the name to Astros to follow along with Astrodome. So that's how they got their name. And that's why Cody was cheering just a minute ago, because of the Astros.
The lone Aster.
Yeah. let's see. Here's a question from Laura. Was there a meteor shower this morning or last night? There was some minor, I think the tail end of a minor shower. The next major one of the Leonids later this month, and the Geminids are in December. And there are several minor meteor showers also. And I'm not sure if we were on the tail end of one of those. We can look that up. Here's a fun question. What's the ratio of moons to planets in the galaxy?
Oh, it's way off. Just because of Saturn and Jupiter, I mean, we're looking at.
Yeah, that's it.
Maybe 1 in 10, 1 in 20, something like that.
And you know, we could just, even if we just look at our galaxy, I mean our solar system, because you know we don't know if our solar system is typical or not. Up until just a few years ago, we knew of one solar system, a star with 9 planets, 9 traditional planets. But you know, recent years we're finding planets around other stars, and they have moons, but it's still early in the stage. In our solar system, we have two planets that don't have moons, Mercury and Jupiter. Mars has 2, Earth has 1. Jupiter's got dozens, Saturn's got dozens. Pluto's got 5 that we know, and these are all that we know of that have been named. So it'll be interesting to see, and this is something our scientists are working on, is characterizing planets around other stars. How many are there? We have no idea. We know better now, maybe, I guess, because scientists are finding new planets every day. But are those planet systems typical? Is ours typical? We don't know. And then moons around them. It's amazing to think, you know, we're not finding moons around other planets yet, but we will eventually. But when you look up at the sky in a dark night, and you can see a couple thousand stars in the dark night, and there are so many more. That's just what we can see in view. And if you think Earth is 1,000,000 times smaller than the sun, so if we're looking up at all those points of light, average stars, you're looking at something 1,000,000 times smaller than a point of light, and yet we're detecting that. It's amazing, the technology. So finding a moon, that's down the road yet around other stars, but it's one of the many questions that astronomers are working on.
Not today, but one day.
One day. Here's a question. Well, here's a fun one. I know it's red because the only light hitting it is the sunset, but why did she leave me? What did I do wrong? I don't know. That's something you'll have to see your counselor about that one. I don't think we can answer that one. So here's another one. Does Lowell have a bifocal Santilli lens telescope? No, not that I know of. I don't think we have anything like that. Let's see. Will it be brighter? Will the brightness of the moon change? The redness, will that get brighter or dimmer as we get toward maximum, you know, the middle of the eclipse? I think that's what that's referring to.
Total eclipse.
We're getting some great comments here that are kind of fun. We'll share a couple of these, but also we want to get to our questions. And in 2 minutes, we're going to just keep chatting here because we have so many good questions. So what influences the speed of a lunar eclipse? And I think that's just, you know, the speed of the shadow moving across.
Yeah. I would say distance.
And here's another one. Like we were starting to talk about this. If the total eclipse moon as is red, is it going to get brighter or not? And probably not. I mean, I don't think that'll change. It'll be probably consistent with it. It's not like, I mean, it's completely eclipsed. It's completely in shadow. Yeah. So it's not like it's
the darker part of it.
Yeah, the darker. It's all of that. Yeah. Let's see. How much of the Earth's shadow? Yeah, gotcha. Oops. Oh, here we have Jude watching from England. Thanks for joining us. And maybe a good time to refresh. How does the lunar eclipse happen? As we're getting our view right now for the next hour and 20 minutes or so.
The lunar eclipse is formed basically by the Earth making shadow puppets on the moon, right? So you get the sun and it's shining its light very brightly, and it's resolving as very straight lines of light, and then the Earth is in the way, and it happens to be shining those direct light, makes that very, very nice pronounced shadow on the moon as they kind of like line up.
Okay. Here's a question from Darwin. Can someone tell me why the eclipse for me is not visible yet, but the moon was just out? Now it disappeared. I guess it depends on where you're located, because not the entire world isn't going to be able to see it. There's a certain path that it's going to be visible, plus we get into daylight also. Here's a question: is this the best it will look right now? I guess that's a relative question,
yeah.
But I'm not sure. I don't see the feed right now, but if it's cloud free, where you're viewing from, or if you're looking at ours, it probably will be. It probably isn't going to get better or worse. It's going to stay like this until whatever time, 4:41 is when totality ends. So yeah, there's keep sending the questions. Let us know where you're watching from. And again, we'd like to thank our sponsors and donors and viewers for joining us. This, sharing astronomy is the core of who we are here at Lowell Observatory. Our founder, Percival Lowell, said, "What's the point of doing science unless you share it?" And as he termed it, he said, "Make people co-discoverers." Mm-hmm. And he did that by giving public lectures, by writing popular books, by being in the newspaper. And we do that today. Our scientists share the results of their research via scientific papers, and by doing public talks, and by going to professional programs. And sometimes the story will share it via media to share it with the world. Our educators share it with on-site programs. Before COVID, we were getting 105,000 visitors a year. And because of that, we were kind of bursting at the seams. So in 2 years, we're opening our new Astronomy Discovery Center. And it's going to change everything dramatically. There's going to be so much more of what we can do. Phase one of our expansion for our public was opening the Geology Open Deck Observatory, mm-hmm. Which is an instant star party. You roll this building back, and there are 6 telescopes. In fact, one of those telescopes, a 5.5-inch tech, which stands for telescope or engineering company, that's what we're broadcasting our view of the eclipse with tonight. That's from our Geology Open Deck Observatory, or GODO, as we call it. So, our science and education is thriving here, and for us to be able to be part of this and share the excitement, it kind of, we're only, we're about 50 feet from where our founder is entombed on site here. His mausoleum is just back from where we're sitting outside this building, and it feels like there's some connection with him, that we're doing what he wanted us to do, to do science and to share it and to inspire people. So we appreciate everybody joining us. So yeah, let's look at a couple more questions. Oops, I stepped the cursor there. When will the next live stream be with Q&A broadcast?
Interactive Stargazing 2.0 with me, John Compton.
All right.
November 17th.
The John
G. Compton. On November 17th, about 10 p.m. Mountain Time. So,
November 17th. What date is that? Thursday?
yeah, it's always on Thursday.
Because that's the same day we're also doing the LDT
Global
10th anniversary. Because this is the 10th anniversary since first light of the LDT. So we've been celebrating every month with that.
That'd be fun. Hang out, bug me on stream. Ask me lots of questions, and send me all your corrections in the Discord.
There is a question from David. Depending on the time zone, why is the shadow in different positions?
It shouldn't be. We're literally just making a shadow puppet on the moon, and so you should be able to see it basically the same from everywhere. It's not like a solar eclipse where the shadow is crossing us, and so you can only see it in certain areas. I don't know, lag? Not on our end.
And will the moon ever turn completely red?
It's gonna be. I mean, it's gonna be as red as it's gonna be, right? I don't think it's gonna be like crazy red. Like if you see the pictures where it looks like red, someone bumped that around in Photoshop later.
Yeah.
There's definitely a red tint to it, and it is very distinct. But unless you're moving some sliders around, it's not going to look like the color of an apple or anything.
So there are a couple of questions about kind of the physics of eclipses and how they happen. Is there anything abnormal happening in our atmosphere when eclipse is happening?
I don't think for a lunar eclipse, at least. Sometimes you get effects from a solar eclipse because it makes it a little bit chillier.
Right, and that kind of leads to the next question. Do some eclipses somehow cause cloudy weather? Lunar eclipses, no, but like you said, with solar eclipses, the sun is being blocked out, so the temperature will dramatically drop, noticeably drop, and you sometimes will get some condensation, some clouds forming. Solar eclipses, totality is interesting because if you're out in the middle of nowhere, it's turned dark, and you start getting nocturnal animals and crickets and things like that you don't get during the day normally. So there are different experiences for sure. Here's a question from Darwin in New York. I'm in New York City and I saw the moon a couple minutes ago, but when the eclipse started, and I'm thinking probably totality, it disappeared. So am I going to have to wait? It certainly can be hard to pick up.
Yeah.
If you're not sure where to look, it can certainly appear that reddish color, but it's not going to be nearly as bright as the full uneclipsed moon.
Yeah.
And so it's going to be kind of over in the west southwest in that area of the sky.
Yeah, Darwin. This is not being able to find it is the cool part.
All right, in just a couple minutes, we're gonna go back to play another video. It looks like the next one is talking about the moon and tides. No, am I in the right time? I might be, yeah, moon and tides. So we'll go back to that in a couple minutes. And we're just still plowing through a lot of questions. Let's see.
Yeah, a lot of questions about it. I don't know if you want to see it. Yeah, it'll pop back out.
Why does a lunar eclipse, why does it take longer, or why does it last longer than a solar eclipse?
I don't know. Let me think about it.
Well, it's the size of the shadow, right? That with a solar eclipse, it's just a very small shadow, and the lunar it's
the moon's shadow as opposed to the Earth's shadow. That makes sense.
Yeah. So we have one more minute, then we're going to go to our next video by Matt Leidy about the moon and its tides. And so let's just take one more. As the meteor shower tonight as well. We're thinking there's not a major one going on right now, but the next major one is going to be in November. So we'll stop taking questions for a minute, and we'll go to this video about tides, and then we'll come back and take some more questions and talk about some other stuff going on here at the observatory. So we'll be back in just a few minutes.
Hello everyone, my name is Matt. I'm an educator here at Lowell Observatory. I hope you all are enjoying the lunar eclipse. I'm going to talk to you all about the moon and the tides. So what exactly are the tides? How I like to think about the tides is the rising and lowering of the level of the ocean. So during the day you'll have high tides, which is going to be the highest point that water reaches along the shoreline, and then you'll have low tides, which is the lowest point that water will reach along the shoreline. And each day you'll have 2 high tides and 2 low tides. Now what exactly causes these tides? What causes the water to move like this? Well, the main contributor is the moon, specifically the moon's gravitational force on the Earth. So if we look here, we can see these arrows on this diagram. These arrows represent the gravitational pull of the moon on the Earth. On the side of the Earth that's closest to the moon, there is the largest gravitational pull, and we can see that with the largest arrow. And as you move away from the moon, the arrows get smaller and smaller because the gravitational force of the moon on the Earth gets smaller and smaller. Now if we go ahead and insert the tidal bulges, we can see that on the side of the Earth closest to the moon, there is a tidal bulge, and this is because the gravity is stronger, so the water gets pulled to the moon. So you end up with a bulge of water. And this is going to be one of your high tides. Now on the opposite side of the Earth, there's actually also a high tide, which is kind of counterintuitive, and it didn't make sense to me at first. There's a couple of ways you can think about it. How I like to think about it is the moon is kind of trying to stretch out the Earth. Since it's pulling on different areas of the Earth with different strength, one of the results is that the Earth is going to get stretched out or elongated. Now what this means is that you end up with a bulge on the side of the Earth that's closest to the moon and a bulge on the side of the Earth that's furthest away from the moon. Another way you can think about it is the gravitational force on the far side of the Earth is so weak that the water doesn't really move. It doesn't really experience a force that would cause it to move, so it kind of just stays there and you end up with a high tide. Now, the moon isn't the only thing that exerts a gravitational force on the Earth. We also have the sun, the object that the Earth rotates around. And since the sun exerts a gravitational force on the Earth, you end up with tides from the sun as well. So I'm going to go ahead and insert the lunar and solar tides. Now, since the sun is so far away, the tidal forces from the sun are about half as strong as the tidal forces from the moon, so you end up with tides that are about half as high. Now, we start here in third quarter. In third quarter, the moon and the sun are not aligned, meaning that the tides don't line up. In this case, you're going to end up with neap tides, which is going to be when you have the lowest high tides and the highest low tides, because the tides of the sun and the tides of the moon are not lining up. Now, if we continue through the lunar cycle and we end up at new moon, now the moon and the sun are lined up. And when these two are lined up, the tides are lined up. This is when you're going to end up with spring tides, which is going to be when you're going to have the highest high tides and the lowest low tides. If we continue through the lunar cycle, next up is first quarter. We're once again going to have these neap tides where the 2 tides do not line up. And then we end with full moon where the tides are lined up once again. And this is where we're at right now. So if you were to go outside tonight, or if you were to study the tides over the course of the next day, you're going to have the highest high tides and the lowest low tides. Now let's get into something called tidal slowing. As the Earth rotates, it actually brings the tidal bulge with it. So if we play this, we can see that as Earth rotates, it rotates the tidal bulge away from the moon. Well, the moon doesn't like this. The moon wants the tidal bulge to be lined up. It applies a corrective gravitational force, trying to pull this bulge back to being aligned with the moon. And this gravitational pulling actually pulls against the rotation of the Earth and slows it down. Every day, this tidal slowing slows Earth's rotation by about 500 billionths of a second. In order for it to slow the Earth's rotation by a single second, you'd have to wait 50,000 years. So not something we're necessarily going to note, but it is a cool phenomenon caused by the moon's gravitational effect on the Earth. I want to thank our members and donors for making videos like this possible and live streams like this possible. So thank you.
Thanks, Matt, for telling us about tides. There's something else we want to talk about today because we have so much programming going on at the observatory, and we have so much fun doing this. And if you love these kind of programs, we also this past year started a podcast by the one and only Cody Halfmoon, who is the head of our marketing department, and also the Astros fan. And she started this with the help of educators, John, and a whole slew of educators have helped out. And it's been so popular that we're going to do it a second season because we're, again, being able to talk to people about this, about astronomy. It's not just science, but there's a lot of cultural stuff. We talk about movies, not, certainly science, but also other things, astronomy in everyday life, science in everyday life. And these are just a blast. And so we're gonna play a little video about season 2, kind of a lead up to season 2.
Incoming transmission.
Can you hear us?
Are we coming in clear?
Can you see us?
I don't think they can see us.
Why can't they see us?
Wait, shouldn't they be able to see us?
Yeah, I think they should be able to see us.
Oh my gosh, that's so much better.
Oh, so that's what you look like.
Get ready for Star Stuff.
A Space Podity.
Season 2.
Coming in 2023 in glorious video format on YouTube.
But don't worry, we'll still be on all of your favorite streaming platforms, including Spotify and iTunes.
Follow Lowell Observatory to stay up to date.
We're celebrating the discovery of Pluto here at Lowell Observatory, and Flagstaff's role as the home of Pluto. And so Don Johanson, who discovered the fossil hominid Lucy, which is also the namesake of the Lucy mission, in which we have scientists involved. He was part of a panel discussion, and it was just a fascinating discussion. And so we've had so many different really neat topics. So let's take a few minutes for questions here. Is the moon still volcanically active?
No.
That's it?
It's just not. I believe it's minorly. You get like moon quakes up there, and that's actually how we know a lot about the subsurface of the moon is by doing geophysical surveys when people were up there, and using those moon quakes to kind of like see what happens when the seismic quakes. Bless me. Those little seismic waves. As the seismic waves go beneath the surface, we can map the subsurface, but it's no longer geologically active, and it's no longer volcanic for sure.
And that's an interesting thing because back in the 1960s and throughout past decades, there were occasionally people looking at the moon that observed what looked like color changes and maybe some sort of activity. They were termed transient lunar phenomena. And in fact, in the mid-60s, there was a moon mapping program going on at Lowell Observatory. Starting in 1961, the Aeronautical Charts and Information Center, which is a branch of the Air Force mapping branch, They were here at the observatory using the 24-inch refractor to create these exquisite lunar maps. And John, we've got one over here. Let's hold one of those up. So they were making these exquisitely detailed maps of the lunar surface. And here's one right here. And these were all done by scientists working with artists. Artists would have basic images of the sky and then sketching the details using airbrushes. And if you use these maps, compare them to modern views of the moon, they're so accurate. And they made them even to have a shadow at a certain angle, the angle that the astronauts would be flying at when they got to the moon. And so this moon mapping was going on in the 60s here at Lowell. And during that time, on a couple different nights, some of the observers, Jim Greenacre, Ed Barr, they were observing with the Clark and noticed some of these green flashes, green color changes, and reported them as some sort of transient lunar phenomena. And one theory was maybe the moon was erupting, maybe there's some sort of activity, but it wasn't. So, there's a lot of things, when you're observing, there's a lot of things you can't explain right away, but then you learn more and understand. So let's get some more questions. Would the moon be red on the surface during the eclipse?
Probably not. I mean, to a very, very small degree. But you wouldn't be able to notice it for the same reason that you shouldn't look at the sun during an eclipse, a solar eclipse. It's because it's sunlight and it'll burn your eyes out. The sunlight coming around would kind of blow out any red that you would notice by just trashing your retina.
And here's a good question that I think answers a lot of confusion about the moon. Will we ever be able to see the dark side of the moon? And that's a good introduction to dark side, calling it dark side versus the near side and the far side.
The dark side of the moon is called the dark side because it's radio dark first. It's basically so the moon is tightly locked to us, where the same side of it kind of is always going to face us. There's some wiggle room, but as the moon gets farther away from us, that will stabilize and it'll stop wiggling. That wiggling is partially why it's moving away, the energy loss. But the back side of the moon, the side we can't see, is the dark side of the moon, and it's always facing away from us, so it's radio dark. So when the Apollo missions kind of like when the orbiter kind of goes around the moon, it's radio dark. They're not going to hear anything from us. It's not necessarily, it's not darker or any darker or lighter back there. It's just the mysterious dark side of the moon.
And there's something curious about that also, because up until the late 1950s, we had no idea what that side of the moon looked like, because if you looked at the moon, you probably noticed it looks the same. And wait a minute, isn't the Earth, the planets spin around and then the moon's orbit, but it turns out where the moon is orbiting at the same speed that is spinning on its axis. So we always see the same face. Let's talk about that a little bit. Why we see the same face all the time.
Well, a lot of it has to do, so we're tightly locked, which means it's always facing us. But realistically, it's a lot like Weeble wobbles. Weeble wobbles wobble, but they don't fall down. So the moon has an offset, very, very dense core, and that offset dense core is closest to us. You can see it bubbling out in the MAR, the dark surface of the moon. Part of it.
It's not bubbling per se, but
it bubbled up a long time ago and is now frozen. But basically, that offset core is facing us, and so as the moon rotates around us, it kind of like early on it wiggle wobble to face us, and now it's kind of stuck in that rotation. But that is why there is that little bit of wiggle as it moves around us as well.
And that happened when the moon was formed. It was just
really
it was still unconsolidated material, but the gravity of Earth pulled the denser
Sparked it out.
materials towards it,
Yeah,
and then
seared it through.
froze it in place.
Yeah. And the moon was a lot closer back then, so it was a much more pronounced effect.
And it's a good time to talk about how the moon was formed also.
Yeah, we got sideswiped by a big old rogue planet called Theia. It blasted off a bunch of lava from the surface of the Earth back in the Hadean time period. Hades, god of the underworld. Also, the equivalent would be Pluto, which we're the home of. So that's cool. But the Hadean time period, the Earth was just a ball of sort of differentiated lava flowing all over the surface. And then we get sideswiped, blows these rocks off. We got rings for a while, rings of rock. They eventually coalesce into the moon as they kind of catch up on themselves as they lap each other.
And that's something interesting we learned from Apollo, because before we went to the moon and were able to collect rocks, there were different theories on how the moon was formed.
Yeah.
Maybe it was formed at the same time, or it was a rogue something that Earth's gravity pulled it in. But by collecting rocks and be able to look at their chemical signatures, we could determine that they were what you find in the upper crust of the Earth.
Yeah.
And I know that there's still some argument about the exact size and nature of that body that is being debated. But again, to me, one of the things we learned from Apollo, learning how the moon was formed is basic to understanding our solar system and how we got here and the origins in general. So it's good to be able to get to the bottom of those things when we can.
Well, with the moon being a piece of the Earth that came off, we can, and it is frozen, no longer geologically active, we can learn a lot about the Earth from it, which I think is fun.
Here's a question. Are there any cameras on the moon to record the solar eclipse?
I don't think so.
I think
there's some busted ones.
Yeah,
they just left there.
I think the best thing probably, there's still scientific equipment on the moon that's still working, detecting moonquakes and such. But I think the closest thing would probably be the moon orbiters. But I don't think that they would be looking out; they're looking down. And I don't know how their cameras work, but they probably wouldn't be pointed this way. Let's see. How wide is the Earth's shadow by the time it reaches the moon?
I feel like it's about the size of the moon. I feel like it's pretty close in size, and we're sort of at that, we talked about that like perfect time period right now where we're in, where they sort of like match up in size, in like angular spread, like apparent size. Before the moon was a lot closer. And so like during a solar eclipse, it would cover a lot more of the sun. But as the moon leaves, that will get smaller and smaller until it'll look more like a transit. And so the same one could be said for Earth's shadow on the moon, that it'll start to cover more and more. The shadow will appear bigger and bigger on the moon.
Okay. And it looks like we're in just a couple of minutes, we're going to take watch another video. This one by Juan Ruiz, talking about the surface of the moon.
My favorite.
Yes. Well, you talk about surface, you're talking about geology.
Yeah.
And the topography, the geography. So there's so many things to talk about. And then after that, we're going to take a break. Just have an eclipse view until 4:20. And so Juan, just an outstanding educator, one of many outstanding educators here. And so we're going to be excited to hear from him. So let's take a couple more questions before then, and then we'll go to John's video, and then we'll take about 15 minutes and just do an eclipse view. So let's take one or two more questions. Let's see. How would the view be from the International Space Station?
So from the International Space Station, they would still see the eclipse, the lunar eclipse, just fine. Because the moon is a sphere, maybe a little. No, you won't. It'll just look basically the same.
Yeah.
Probably a lot clearer. No clouds.
And that you see the astronauts, they've watched eclipses from the space station before and gotten pictures of it. You imagine, I mean, they're not that far up there, but it's a different view. You don't have the atmosphere to look through. You don't have to worry about clouds and that sort of thing.
Everyone thinks about the ice as being like way out there, but it's really close.
Yeah, it's not that
It's
far
like
up there.
really, really close. It's just whipping along.
Yeah. All right, well, let's play Juan's video about the surface of the moon, and then after that, we'll just go into a break until about 4:20, where we can just enjoy views of the moon.
Hi, how's everyone doing? My name is Juan Alberto Ruiz, and I'm an educator here at Lowell Observatory. And I'm going to talk to you about lunar features today. So the way we have observed the moon has changed drastically throughout human history. Whenever you look up and see a full moon with your naked eye, you can clearly see lighter and darker patches across the surface. Cultures from all across the globe have seen things across these contrasting surfaces like a man or a face or even a bunny. But the lighter patches are what we refer to as the lunar highlands. This is where you tend to see the most craters. The crust is the thickest in these areas and tends to be older than the darker patches. The far side of the moon is covered with craters in the areas we also refer to as highlands. The biggest moon's craters can be found on the far side. It is known as the Icon Basin with a diameter of 2,500 kilometers and a depth of 12 kilometers. The dark patches are known as the mare, and that is Latin for sea because at one point in human history, we actually thought the moon was filled with liquid water. We now know that mare are some flatter, smoother areas on the moon, and it's filled with a lot of basalt. Now, we think that this area on the moon is a lot thinner compared to the crust on the highlands. So we believe that these giant impacts from meteors and comets actually broke through the crust into the mantle, and all that molten rock, the magma, actually erupted towards the surface and completely filled the near side of the moon with magma, which eventually cooled off and left us this flat, darker areas that we refer to as the mare. These areas are younger than the highlands, and that is why we tend to see less craters. Remember, the moon also does not have a magnetic field or an atmosphere. So these areas are also younger because we believe that they have not been exposed to the sun as long. So they are not as sun bleached compared to the highlands. Some of the easiest features to see on the moon are the Tycho, Copernicus, and Kepler craters. You also want to look out for those notable mare like the Sea of Tranquility where the Apollo 11 mission landed, and others like the Sea of Crisis or the giant ocean storms. The moon also has valleys and mountains very similar to those what we have here on Earth, but the thing is that the moon does not have plate tectonics. We believe that these mountains were formed from these giant impacts that actually lifted up the crust towards the surface and gave us these huge mountain ranges. The most notable mountain range is the Apennines Mountains, where you can find the largest lunar mountain known as Mont Huygens. And this is a giant mountain standing at around 18,000 feet or around 5,500 meters. These mountain ranges can be found separating the Sea of Showers and the Sea of Serenity. The moon even has some weirder features like these lunar swirls that look like paintings all across the surface of the moon. One of them is an anomaly that we refer to as Rainer Gamma. And these are just few of the very prominent lunar features that you can see with your naked eye and through a telescope. Our understanding of these features will only continue to progress as we continue to study our closest companion and one day return to its surface. I want to say thank you to all the members and donors that support Lowell Observatory and make all of this possible.
Well, welcome back. We stepped outside to take a look at the moon, and we have some clouds going on right now. So Sarah, up at the telescope, Sarah Birchler, manages all of our public programs and is fighting the clouds tonight. We're kind of go back and forth between live views and some stored images we have as the clouds permit. So the good thing is most of the time we've been able to see the live view up till this point. So we're going to watch another video right now about Artemis. And Artemis is the mission we were talking about earlier, the next crewed mission to the moon. And Gavin Moriarty is going to talk about Artemis. And I'm not sure if we'll talk about the name, but the original mission to the moon was Apollo, and Artemis was Apollo's sister. And that's important because one of the first goals of Artemis is to send females and people of color to the moon. And then from that, there's going to be so many more missions and moon bases and all that stuff that's being planned. So let's go to Gavin's video right now.
Hi, I'm Gavin Moriarty. I'm an educator here at Lowell Observatory. We are just around the corner from the biggest human space exploration in over 50 years. NASA's Artemis mission will be the next step in human space exploration. By 2025, NASA plans to land the first woman and person of color on the surface of the moon. Let's see what we can expect from NASA in the coming years. The Artemis missions are just about to start, and by soon, I mean like this year. At the end of April, NASA just completed their wet dress rehearsal. This is exactly what you think of a dress rehearsal, with taking the rocket onto the launch pad and going through all the motions of a real launch, but the wet part of it means that they fueled the rocket, and so they could actually test all the fueling systems before launch as well. And it's a good thing that they did, because they did find some problems, and they're currently already fixing them, and so we're expecting a launch in August of this year, somewhere around there. So what are these missions actually going to look like? The first one will launch in August of this year, and that'll be an uncrewed mission where the Space Launch System, the new rocket that NASA is going to be sending up, will have the Orion capsule on it, and they're going to do an uncrewed mission that will last about a month, just going through the orbits of the Earth and the Moon. And then in 2024, we'll get the first crewed mission. This will be called Artemis 2. And this will act the exact same as the uncrewed mission, going around Earth and the Moon as flybys, and will still last about a month. And then the best part, in 2025, we'll have Artemis 3. That is going to be the crewed mission where we will land on the moon for the first time since 1972. On that mission, 4 people will launch in the Orion capsule, and 2 of them will be chosen to walk on the surface of the moon. They'll spend about 6 days there doing scientific observations and testing out some systems. And hopefully, if all goes well, we'll get more missions following Artemis 3 in 2025. That's not the only thing that NASA has planned in the coming future. As well as the Artemis mission, NASA is also planning to build their Lunar Gateway Station, which is going to be an orbiting space station around the moon that will be a checkpoint for future moon missions and for hopeful human deep space travels. And so they're already building pieces for that. We're hoping the first pieces will go up in 2024, and the important pieces, with including the human landing system, will be there by the time Artemis 3 reaches the moon in 2025. And then after this, they'll keep adding pieces onto it, more science, propulsion systems, and my personal favorite, the Canadarm3. Away from the moon, NASA also has the Psyche missions happening. And so the Psyche is actually an asteroid in the asteroid belt that we think could have actually been the core of an early planet of our solar system. And so the Psyche mission is currently in development by NASA's JPL, or Jet Propulsion Labs, and is being tested for hopefully launching at the same time as Artemis 1 in August of this year. And so that'll take a couple years to get to the asteroid in question. It'll do a little slingshot around Mars, a little flyby, and then it'll meet up with its asteroid in 2026. And then it'll spend about 20 months or so orbiting around this asteroid and mapping it out, trying to study the properties of it so that hopefully we can understand a little bit more of what actually happened in the early solar system. There are plenty of awesome missions that NASA has in store for us in the future, so keep an eye out to learn more about what is currently happening in the realm of human space exploration. Thank you to our members and donors for making this video possible.
Well, thanks, Gavin, for that great video. And one thing we should point out, when Gavin was talking about Artemis, is that segment was actually filmed in August. That was before the delay in the initial launch. The launch now is set for, I believe it's the 14th. Although there's a tropical storm moving toward Florida, timed around that time, so I'm not sure how that may or may not affect it. But Artemis is so exciting, and as we mentioned before, you know, the astronauts came here in the 1960s, but not only that, we had geologists here and engineers developing equipment, testing rovers, backpacks they would carry on the moon, the tools they would use, and that's happening still here in northern Arizona. Just a couple weeks ago, the desert rats were here, and desert rats, it stands for I just forgot. It has something to do with technology and testing equipment. And they were here and testing. One of the things they had was a rover, and I got to ride it. It was pretty cool. But they're also still training the astronauts. The 2017 class has done a lot of training here, and the newest class, I think they're coming out anytime. A couple geologists over at the USGS, Jim Skinner and Lauren Edgar, lead that effort to where they do some classroom training and then take the astronauts to the same places, in some cases, where the Apollo astronauts trained. And so that stuff that happened 50 years ago is not just a historic footnote, but the foundation for what's happening today. And I think one of the exciting things about Artemis is it's a new generation. You know, kids today, Apollo doesn't mean much, but to see people going up there, it's going to be very inspirational, I think.
Yeah.
You know, we're explorers at heart, and to be able to see our species go up to another world, I think jealousy is one thing that I feel.
Yeah, for sure.
So, gosh, we only have, I don't know what happened to the time, but we're less than 20 minutes from totality ending, and then we'll go back into partial eclipse phase. And again, we've been having some clouds moving in. Luckily, we had, for most of our broadcasts, we were able to see a live view. We've had some clouds move in. So Sarah Bircher has got some excellent photos that are still taken earlier this night of the eclipse. So we're still going to try to go in and out between live views and views that we got earlier tonight. But we actually just have a little bit of time left here. I think, gosh, 12 dozen minutes or so we'll talk, and so we'll try to take some more questions for the next dozen minutes, and then we'll sign off and just leave everybody with some final views. But again, John Compton, Kevin Schindler, we are here live from Lowell Observatory, and our behind the scenes crew that's making it all happen: Sarah Bircher, Cody Halfmoon, Heather Craig, and Nate Nice. It's just a great team effort, and to be able to share these views and what's happening with people around the world is really exciting for us. That's the core of what we do at the observatory, is to communicate science and share that inspiration. And so we're really pleased to be here. We really appreciate our donors and sponsors. We have a Friends of Lowell Observatory membership that you can sign up and become members and get regular updates about science and education that's happening, admissions to the observatory, discounts in the gift shop, admissions to science centers around the country. So if you want to learn more about Lowell or be part of the Lowell team and be a member, certainly consider joining the Friends of Lowell Observatory. So John, we've just got a little bit of time left. Just let's take some more questions.
Yeah.
Here's one that's been waiting for a little bit. Let's go back a little bit and talk about the coincidence of when we're talking about the eclipses. One of the reasons they're possible is because the apparent similarity in the size of the moon and sun. So let's talk about that a little bit.
I mean, it is pure coincidence. It's beautiful, wonderful coincidence, but you know, the moon is small compared to the Earth, but it's still huge, right? It's still a giant chunk of stuff. And it came from the Earth, and it was a lot closer at some point, and it's slowly drifting away. And it is kind of just a wonderful serendipity that it happens to be the right size to cover the sun almost perfectly, which means it's gonna will cast that nice shadow over us, and we'll cast a nice shadow over it based on the sizes they are and the distances they are. But yeah, it is just pure coincidence.
And it is neat. I mean, we live in a time when we have a North Star that's pretty darn close to true north, close enough to be accurate. Go back in time, and there's not a really good brightest star in that direction. We just happen to live at a time, because the Earth is spinning on its axis once every 26,000 years. Right now, we just happen to be pointing real close to Polaris, which is the 51st brightest star in the night sky. But the same thing with the size of the sun and the moon. That the sun is 400 times larger than the moon, but it's 400 times further away. So they appear to be the same size. What that means is in 50 million years or so, as the moon keeps getting further and further away, it won't be big enough. We won't have total solar eclipses anymore. We'll have annular eclipses for a while.
Yeah.
But it's just amazing. We just happen to live in this time right now.
We'll call it the lunar transit eventually.
I'll call it the John Compton transit. Let's scroll through some more things. And again, we'll continue trying to get live views as we can. If not, we'll show images we took earlier in the night.
Speaking on the, I guess while we're looking for more fun questions, when the moon was a lot larger in our view, some people believe that during a solar eclipse, that's where we get the like the Eye of Ra like symbolism, like specifically the lines coming off is part of what the solar eclipse would have looked like back in the day, based on like diffraction, because you're not going to get that perfect view. It's going to cover it up, and you're going to get these lines coming off it, which is super neat.
And we have just 9 minutes of totality left. The last totality of the moon we'll have until 2025. So enjoy it while we can. Another question we have is, what is Artemis 3? Well, Artemis 1 is the one that hopefully is going to launch on the 14th, and that's an uncrewed mission. If all goes well, and I think the timetable still holds in 2024, Artemis 2, with people on it, will fly to the moon and orbit around it. And if all goes well, Artemis 3, the following year in 2025, is when humans will again step foot on the moon, returning for the first time in 50 years, or I guess more than that, 54 years by then, or whatever it will be.
I will not be one of those people, unless get in the comments.
All right, let's scroll through here. Oops. So let's see here. John, maybe you can, while I'm looking through our comments here, maybe you can kind of recap what we've seen tonight, the eclipse and why we're seeing it.
Yeah, so we're basically seeing the Earth making shadows on the moon, right? So the sun is shining bright as ever, beautiful soul, shining light, and the Earth is sort of passing or the moon is sort of like passing into the shadow of the Earth, and Earth is literally throwing shade on the moon. It's where we get a lot of the terminology. So penumbral and the umbral and the totality phases, like so umbral, like umbrella, means shade, right, or shadow, and so we're getting you imagine a blank spotlight of shadow, whatever you call that, out in space, and the moon is slowly passing through it. And when it's in totality, it's sort of completely in that spot shadow, but it's going to start passing back out into the umbral and penumbral phases, and then be on its merry way for the next 3 years or whatever.
Okay. And we got another question asking about, we mentioned before about an event we're doing in 2024. That's the solar eclipse. And that's Eclipse over Waco Live 2024. That's going to be, total solar eclipses aren't nearly as common. And we had one, you think, oh, we just had one a few years ago in 2017, where it stretched across a big swath of the continental United States. And the one in 2024 is gonna come up from Mexico through Texas, kind of stretching to the northeast. It'll go through my hometown in Ohio, although April in Ohio isn't a good time to look at the skies. But it could work out up into New York and beyond. And so that's going to be another so-called Great American Eclipse. That's going to be, for most of us, unless you chase eclipses around the world, that's going to be our last practical time to see a good solar eclipse, total solar eclipse. So Lowell Observatory is doing an event in Waco in partnership with the city of Waco and Baylor University. It's going to be centered right around the football stadium, both inside and outside. So, our people tailgate for football parties, football games. Will be tailgating, as it were, with telescopes and all sorts of great activities. And Discovery is going to be broadcasting that around the world. And so that's where the 2024 event is going to be. We're excited about that. So we're let's see, 4:37. We're just 4 minutes from Totality ending. And in fact, when Totality ends, we're gonna sign off, and hopefully we'll still be able to give you some live views. I'm trying to get as many live views as we can because of clouds. We're going back and forth between that and some views that Sarah Bircher got early in the night. So John, let's just take this last few minutes to thank everybody who's watching, and we've got a couple more questions
We got time for some more
to take here, and then we'll sign off in a few minutes. Another question we've got that just came in: how long will the moon take to get from totality back to normal? And so totality ends at 4:41, and then at 6:56 is when the partial ends. And that's the umbral partial. The penumbral, as John was talking about, you can't really tell. There's a shadow, but you can't really see it. So when we think of the eclipse, well, we'll see it ends at 6:56. And for a lot of people, you're in daylight. You'll be in daylight, so you might not see it, or it won't be obvious.
Yeah. See, do we have any other fun questions?
So the umbral eclipse actually ends earlier than that. The penumbral is 6:56, so it'll be before that it'll be ending.
Like nothing ever happened.
Yeah, it'll be back to normal. And the lunar eclipses they're fun because they're kind of eerie, especially if it's partly cloudy or clear. When you get that reddish moon, and that's why some people call it the blood red moon. And in culture, sometimes that's been some portent of doom. There's a great story from history. Christopher Columbus, when he was on one of his trips to Jamaica, he had lunar tables, he had astronomy tables, and knew that a total lunar eclipse was coming. And there was some fighting going on among the people there. And so to try to calm them down, he said, if you don't settle down, I'm going to take the moon away from you at this time. And he did. And the moon started getting dark, and then it went, it eclipsed. And that got by everybody's attention. And, essentially, okay, we'll be good. Okay, I'll bring the moon back.
Turn this moon around.
Right. And so we use that knowledge to that's kind of an interesting tale. It's been great to have this feed tonight and to be able to view live from Lowell Observatory. Sarah Bircher has been just doing an incredible job with the telescope. It's always a challenge when you're doing astronomy and there's clouds, because we want to show the best we can. Luckily, we had such a clear night, a clear sky earlier on, that she was able to get all sorts of images early. And so the latest ones we've been having are kind of a mix of live images and some recorded earlier in the night. So thanks, Sarah, for doing all that. Nate, Cody, and Heather keeping us going behind the scenes, because there's several different systems working here and communication is critical. And we certainly thank our viewers for watching, because this is, again, this gets at the core of who we are at Lowell Observatory, communicating science and sharing the inspiration of the cosmos. And so that it's been really great in our supporters and donors who watch these programs with us, and for all those of you who wrote in questions and comments. We got a lot of great comments, some that we didn't put in, we didn't say, they were on the YouTube feed, but besides questions, there were a lot of fun comments about people's experience and where they were viewing from and such.
We have a great community here.
Yeah.
Appreciate y'all for being part of it.
Well, thanks so much for joining us, John. It's been great again.
Yeah.
And suddenly the eclipse is over. It's ending right now. So we'll sign off and leave you with some final views of tonight's eclipse. Enjoy and thank you.
Bye, nerds.